The universe has a strange sense of humor. Just when humanity believes it has mapped the rules of the cosmos, something appears that breaks every single one of them. Meet 3I Atlas, a cosmic enigma that is rewriting everything we thought we knew about interstellar visitors. At first glance, it appeared harmless, just another comet in the night sky, bright and distant. But soon, astronomers noticed something unusual. A faint, ghostly tail began forming. Not quite a comet's tail, not quite anything we had ever seen before. Then the numbers came in. A 73 trillion pound object racing through our solar system at an astonishing 124,000 miles per hour, with a light signature unlike anything ever recorded. Extreme negative polarization, something no comet, asteroid, or interstellar object had ever shown. Even stranger, its trajectory aligns within just 5 degrees of Earth's orbital plane, a precision so rare it's nearly impossible by chance, a 1 in half a million coincidence. Its flyby of Mars was timed with similar precision, so unlikely that the odds of it being coincidental are less than 1 in a million. Harvard astrophysicist Avi Loeb, known for his research into interstellar objects, estimates there's a 30 to 40% chance that 3I Atlas isn't a natural object. And then, the data stopped. During the US government shutdown, right as Atlas made its closest pass to Mars, NASA's live data feeds went offline. For days, the world's scientists were blind, at the exact moment when their eyes were needed most. Coincidence? Perhaps. Convenient? Definitely. What we do know is undeniable. 3I Atlas has shattered every expectation we had about interstellar objects. But what's truly unsettling isn't what we know, it's what we don't. Unlike the cigar-shaped Oumuamua or the icy comet Borisov, Atlas doesn't fit any known category. Its mass is staggering, over 6 million times heavier than SpaceX's Starship. Even as it spews gas and dust, its trajectory barely changes. Normally, comets venting gas act like tiny thrusters, nudging them slightly off course. Atlas doesn't. Its immense mass renders these effects almost negligible. Then there's the origin problem. Interstellar space contains far too little solid material to form something of Atlas's size, let alone send it into the inner solar system. If such objects were common, we would have detected hundreds of smaller ones first. We haven't. There's just not enough rocky material out there, Loeb said. Not in the last decade. Not in the last millennium. And then there's the trajectory. Unlike most interstellar objects, which drift in from random directions, Atlas follows the ecliptic plane, the invisible highway along which all planets orbit the Sun. It's almost as if it were following a deliberate, calculated path through our solar system. Atlas passed within 18 million miles of Mars. The Perseverance rover captured something streaking across the Martian sky, a tilted, glowing line that matched no known satellite, star, or meteor trail. And once again, NASA's live feeds went dark. Before the blackout, the observations already hinted at something extraordinary. Atlas appeared elongated, reminiscent of Oumuamua, but it lacked the long, flowing tail typical of comets. Instead, it glowed faintly, surrounded by a hazy envelope of ionized gas, moving in ways no comet, asteroid, or planetesimal ever had. Its spectral readings confirmed the presence of cyanide and carbon monoxide, normal for comets, but also detected traces of Martian atmospheric chemistry. Could this object have originated from a planetary surface rather than interstellar space? The real test of Atlas's resilience came on September 25th, when a massive coronal mass ejection, a solar storm of charged plasma, slammed directly into it. Under normal circumstances, a comet of this size would have fragmented, flared brightly, or erupted in a dramatic burst of gas and dust. Atlas didn't. 2 days later, it remained perfectly intact, with only a slow, measured expansion of its outer envelope. It was as if the object absorbed the impact rather than being destroyed by it. Its ability to withstand such forces suggests a composition radically different from any known comet, or perhaps, as some theorists propose, engineering at a scale far beyond our understanding. Then came the discovery that truly stunned astronomers. When sunlight reflects off cometary dust, it produces positive polarization. Every comet ever observed does. Every single one, except this. 3I Atlas exhibited extreme negative polarization, about -2.77% at a phase angle of 6.4 degrees, far beyond any measurement in recorded history. This suggests the dust around it is unlike anything in our solar system, sharper, irregular, or potentially manufactured. Combined with its near-perfect ecliptic alignment, the coincidences pile up. Atlas is traveling a path that allows it to pass Mars, then Jupiter, and potentially beyond, almost as if its trajectory had been carefully engineered to observe multiple planets. Several scientists have proposed hypotheses. Dr. Suzanne Fanayer, a planetary formation expert, suggested Atlas could be a planet seed, a massive chunk of material ejected from another system that could trigger rapid planet formation upon entering a new system. Simulations suggest such objects could accelerate the creation of planets, compressing dust clouds into worlds far faster than previously believed. Some theorists even speculate that gas giants like Jupiter may have been influenced by such interstellar objects. Yet these theories cannot explain Atlas's speed, size, or composition. Currently traveling at over 37 miles per second, accelerating to 42 miles per second as it nears the Sun, Atlas carries a kinetic energy beyond comprehension. Its nucleus, roughly 3 miles wide, is a mountain-sized projectile with unknown chemical and physical properties, capable of surviving millennia in the vacuum of interstellar space. While NASA's feeds went dark, the European Space Agency continued monitoring Atlas. The Mars Express and ExoMars Trace Gas Orbiter captured high-resolution data, and the JUICE spacecraft, en route to Jupiter, will pass close enough in November 2025 to collect unprecedented measurements. This may be humanity's final chance to study 3I Atlas up close before it vanishes into the outer solar system. Even small details, a surface glint, reflective pattern, magnetic field anomaly, could reveal whether Atlas is natural or artificial. At the moment, the world waits, data streaming in slowly, with every observation deepening the mystery. No single anomaly proves anything. Taken together, they form a pattern that is impossible to ignore. Mass is too high. Composition is too exotic. Timing is too perfect. Trajectory is too precise. Polarization is unique. Structure hints at artificiality. Brightness pulses rhythmically, almost like a signal. Even Loeb calls it a black swan event, something so improbable that it forces science to rethink the fundamentals. Atlas's brightness fluctuations are particularly curious. Sometimes it glows faintly, like dying embers. Other times, it pulses with light that rivals nearby stars. Some astronomers argue these are simply reflections from rotating surfaces. Others whisper about controlled modulation, patterns of light that could be technological in nature. This brings us to the most unsettling theory, the Trojan Horse scenario. What if 3I Atlas isn't pretending to be a comet by accident, but by design? Imagine a probe crafted to look ordinary, drifting silently through space for millennia, only revealing its presence to civilizations advanced enough to notice. If you were an ancient civilization observing distant stars, you wouldn't send flashy spacecraft. Instead, you'd send something that appears natural, a comet-like object capable of silently observing, gathering data, and transmitting it only when near planets worth studying. Gas jets, dust clouds, even faint outgassing could be camouflage, masking propulsion or sensor systems. Its near-perfect alignment with the ecliptic, intentional, an optimized survey route across multiple planets. Its ability to withstand radiation, the negative polarization, the rhythmic pulsing, and extreme mass, all could be features, not accidents. A machine forged millions or even billions of years ago, drifting between stars, silently observing civilizations as they rise and fall. As Atlas heads toward Jupiter, every telescope on Earth is trained on it. Once it slingshots past the Sun, we may never see it again. On December 19, 2025, it will pass 167 million miles from Earth, our final window to observe it before it fades into the cosmic dark. After that, all we'll have are the data and the questions. Is it natural? Artificial? A probe sent across the galaxy? Whatever the truth, 3I Atlas forces humanity to accept a profound reality. The universe is far stranger and more complex than we have imagined. 3I Atlas is already rewriting astronomy. It demonstrates that interstellar visitors can be massive, complex, and defy classification, forcing us to confront possibilities we never considered. Perhaps it's a freak of nature, a cosmic accident born of physics and chance we don't yet understand. Or perhaps it is something far older, a probe drifting silently through the galaxy, observing Earth as we now observe the cosmos. Either way, the message is clear. Keep watching the skies. If 3I Atlas truly came from beyond, it may not be the first, and it certainly won't be the last. If you enjoyed this video, smash that like button, subscribe, and let us know what you think in the comments below. Thank you for watching.